Two-car competition, M&M quiz 2044. Two cars have the same maximum speed. Both cars are capable of constant acceleration. Both cars start from zero. Does it matter which car you choose to win a short distance car race? A, it does not matter. B, it does matter. So by definition, acceleration is equal to change of velocity divided by time. Let's assume that delta t is t minus 0, and that is just t. And delta v, v final minus v initial. Delta v, change in velocity, is v final minus v initial. So we get a is equal to v final minus v initial. Please don't forget, acceleration is a vector, v final is a vector, v initial is a vector, and divided by time. So you cross multiply and you get a times time, acceleration times time, is equal to v final minus v initial. And so we get v final is equal to v0 plus at. Both cars are starting from rest. So this whole thing goes to 0. So we get v final is equal to acceleration times time. Let's assume that our car can reach a maximum of 120 meters per second. Let's pick a number like 120 meters per second. So the maximum speed is 120 meters per second. V final is equal to initial plus acceleration times time. So this is acceleration 1 and this is acceleration 2. If acceleration 1 is 12, from 0 it becomes 12. From 12 it becomes 24. From 24 it becomes 36. From 36 it becomes 48, 60. Now if it is 20, from 0 it becomes 20. And from 20 it becomes 40. From 40 it becomes 60. From 60 it becomes 80. From 80 it becomes 100. From 100 it becomes 120. 0 to 20, 1, 2, 3, 4, 5, 6. 6 seconds. The second car reaches 120 meters per second in 6 seconds. The first car reaches 120 meters per second in 10 seconds. Let's see what happens at the end of 5 seconds. At the end of 5 seconds, the first car is at 60 meters per second. At the end of 5 seconds, the second car is at 1, 2, 3, 4, 5. The second car is already at 100 meters per second. 100 meters per second, 60 meters per second. What travels the most distance? Definitely 100 meters per second. So we choose the one with the bigger acceleration. So that's what I did here. Final velocity is equal to initial velocity plus acceleration times time. Final velocity for the second car equals initial velocity plus acceleration times time. Please don't forget, we are assuming uniform acceleration. Uniform acceleration. Acceleration is how much your velocity changes every second. Acceleration 1 is 12 meters per second every second. Velocity changes by, the change of velocity is 12 meters per second every second. The acceleration 2 is 20 meters per second every second. The velocity changes by 20 meters per second every second. So for the first car, after 1 second, it increases by 12. So our speed is 12 meters per second at the end of 1 second. It is 24 at the end of 2 seconds. It is 36 at the end of 3 seconds. 48, 60, 72, 84, 96, 108, 120. It's going to be 10 seconds before we can get to the maximum speed of our car, 120. Both cars have the same maximum speed, 120 meters per second. What is the unit? 120 meters per second. Now let's look at the second car. It has an acceleration of 20 meters per second every second. So what is the speed? After 1 second, it increases by 20. So this is 20 meters per second. After 1 more second, it is going to be 20 more. and that is 40, and that is 60, 80, 100, 120. So at the end of 6 seconds, it is 120 meters per second. Let's look at it. At the end of 5 seconds, what do we have? At the end of 5 seconds, for the first car, it is 60 meters per second. At the end of 5 seconds, for the second car, it is 100 meters per second. Definitely 100 meters per second cover more distance than 60 meters per second. So you are covering more distance. Because of that reason, we choose the second car. Our goal is to get to the finish as soon as possible. And this is George Mathew signing off for both myself and my dad. Good luck.